And we're live. Okay, welcome everyone to the August 12, 2020 Node.js Diagnostics Deep Dive Working Group meeting. Today we still have to decide what we are going to be talking about today. Probably about the unexpected behavior user journey, but we might decide another topic. But before that, does anyone have any announcements to make? Okay, so moving forward to the suggested agenda for today. Let me share my screen. Okay, so we have a few topics we can discuss for deep dive. The suggested one is continuing deep diving on user journeys. And user journey we are currently at is unexpected behavior. I'm not sure if anyone read the document we have, but I think we are finished or almost finished. So we can either review it and if not move to another topic, or we could move to another topic and review async. I think both options work for us. So I will leave this open to working group members and suggest what you would like to do. So let me list the deep dive options we have. Triaging existing long-standing issues. So this one is basically going through the backlog of issues on the repository and deciding if the issue should stay open or not. We already closed some using the stay-bot, but some issues are not as clear if they should be closed or not. So we should probably do it together. Just make sure we are not closing anything important. The next possible topic is list subsystems which would benefit from trace points. So we have trace points on Node Core, and for those trace points to be useful, they have to be instrumented on the right subsystems. We don't have a list of systems that have trace points today, and we also don't have a list of subsystems that we want to have trace points. So this deep dive is basically going through the subsystems on Node Core and deciding which systems we want tracing, and maybe deciding what kind of tracing we want for each subsystem. The next one is continue unified hooks discussion. So this discussion started at the last summit. I know Stephen suggested we discuss it a few times. I don't have much more context, so if Stephen wants to give a quick summary.
Yeah, so that's basically just like currently we have async hooks into the lifecycle of async tasks. And then there's like a bunch of other needs around hook systems that seem to overlap a lot in like specifically like where in the code these things need to happen. So I wanted to just kind of get some people thinking about like what are the overall needs of hook systems and how can we share code between them so we don't have like 10 different things trying to make like 10 different entries into JavaScript and just creating a lot of extra unnecessary overhead.
Thank you. The next option is production readiness guide. So while working on the user journeys guide, we noticed that some of the tools we were proposing um, a need the server to be preemptively set up in a certain way. So the idea of production readiness guides is a deep dive similar to user journeys, but we would be talking about um, what are some best practices for users when deploying something to production, based on different environments, etc., and different needs, so that the user has proper access to diagnostic tools. The next one discuss usage and support of Ebpf. So the idea behind this deep dive is to go back to the user journeys documents and identify any points where Ebpf tooling would be useful. This is probably 1 or 2 days deep dive. The next one, which is the one we currently we're doing, is the best practices guides, which is basically the user journeys discussions we've been having. And the last one is Diagnostics Channel. I think this one was also added by Stephen.
Yeah, so I'm currently working on prototyping that. There's the original Diagnostics Channel project from Microsoft like a few years back, which got a bit of pushback from the core just on performance concerns. So I'm trying to like redesign the API in a way that basically the intent is to have just like a unified data fire hose effectively that anyone could just like send data about whatever diagnostic related information they want, and then like consumers could say, I'm interested in this. And the intent is to have like a fire hose. We can send lots of data at it, but we don't want to have a significant performance cost to doing that. So I'm redesigning the API a bit to try and take a lot of the cost, at least out of the like regular publish time, like runtime points.
Thank you. So, sorry, were you going to say anything?
No, I'm done.
Okay, thank you. So these are the options. Any suggestions on what we should talk about? Stephen, if you're ready to talk about continuing unified books discussion or diagnostics channel, I think this would be a good idea for the deep dives today. Otherwise, we can go back to the unexpected behavior user journey.
Yeah, I'm good with either.
Okay, let's talk about the diagnostics channel then, since I think seems like you've been working more on that and more recently.
Yeah, that and the unified hooks discussion kind of relates a bit, I think. Yeah, I'm currently on a contract to work on Diagnostics Channel though, as my main priority. Which yeah, the Diagnostics Channel, the original API was like really simple, just publish function and a subscribe function, and you just give it a string name, and it's little more than an event emitter. And there was a bunch of cost to that, especially given that the intent of Diagnostics Channel is to be like a data fire hose. It's like everything should be able to send diagnostic data to it. So theoretically, you might have like hundreds of modules in your dependency graph are all throwing a bunch of data at this fire hose, and each has their own like namespace within this, and like the like basically event emitter design of before is kind of costly, having to do all these lookups all the time. So I'm kind of restructuring the API bit. I can show you. I have, I'll paste in the chat. I have, that's the state of the prototype as of Monday, I guess. I have some local changes that I haven't synced to that. And I'll paste another thing, which is I made a similar project several years back, which was trying to achieve a similar kind of idea, but basically having like a generic data layer and layering APIs over top of it to do more complex structural things. As this one, universal monitoring bus, there's like most typical like APM products have like spans and transactions and those sorts of things. And what that project does is it has like an underlying data channel that like just emits events that correspond to like the lifecycle events of like spanner transaction, and then there's an object that just kind of aggregates that and like expresses that abstractly. So, do you want to look at the example for universal monitoring bus?
It might be better if you go through the examples. Otherwise, we will be just reading code here.
Yeah, I can share my screen if you want, or
let me stop sharing mine.
It's not. Just have to find links. Just like share screen. Okay. You can see.
Yes.
Okay. So there's this like general monitor thing, which is the equivalent of Diagnostics Channel, which is just a data channel that you have a bunch of messages coming through, and this has this like object style watch query thing, but I'm going for a string version because that's easier to pull out of van. But then there's like this span object has like start and stop functions and things like that to express like, the life cycle of a span. But all of these spans go through. All these spans just go through this monitor watch thing. It just watches for like any span events and puts it into this span aggregator, which basically reconstructs this like event sequence into span objects. And this is the general idea of just make a log and then create APIs on top that we can rebuild the log into something structural. And so like this could just as well be done in another process. Like we just send the messages to somewhere completely different and then like run this span aggregator thing there instead of in the same process. And so it introduces a lot more flexibility that way. We could like send all the log data to some other server entirely and have it be responsible for reconstructing the graph. And like that helps a lot with performance. It's like the biggest challenge with APMs is they tend to try and like make a lot of structural analysis of the system at runtime, and there's a bunch of overhead to like creating all this structural representation of things in memory. So if we just get it out of the process as fast as possible, then that helps significantly to eliminate the like runtime overhead of APMs, which is a huge advantage. As I'll show you the span. There's a span. It has like a bunch of messages. So the span has like some lifecycle functions. You tell it when it starts, when it ends. You can annotate it with extra stuff like log messages. And like each of these correspond to these message types, which this first thing is a subtype. So you receive a message that like this basically results in a JSON object that has like type equals span, subtype equals maybe start or end or annotation, and a timestamp marking whenever that event happened in the lifecycle. And edges are saying like this is a result of this, or like this connects to this somehow. So like there's like if you have a single span, it's going to have a start and an end. The end should link back to the start, so you can rebuild the graph from that. You may also want, if you have a span within a span, like if you have like, you're measuring like two synchronous things, one's like an outer look at like, I don't know, my Express app is doing routing, and now my Express app is doing rendering. All this activity in the middle here is synchronous, but I care about these two different things a bit differently. So you can have the end of the like routing layer, say, like for example, link back to the end of the end of the rendering layer, in addition to its own start. So you can have a little more structural like shape to the graph. Yeah, all of this is just high level abstraction over this message type though, which is basically just this. It's a general bag of data that gets sent to the monitor. And like the monitor itself doesn't care what it looks like. All it cares is it's receiving a JSON object or like something that it can emit. It's the same as like an event emitter. The extra arguments after the name of the event you're emitting, it's just whatever you want it to be. And that's the basic idea I'm trying to go for, is like make something that we can layer stuff on top of like this, to do the more complex structural kind of stuff if we want, but try to eliminate the need for that extra overhead unless we actually need it. And so the Diagnostics Channel prototype, got at that now. So this, I have some local changes to it, which I'm testing a slightly different idea, but the basic concept, I'll show you the use of it. No, I guess that's in the benchmark stuff a little more. It's not super clear here, but there's like a subscriber API. Rather than like in the original Diagnostics channel, there was like very similar to event emitters. You'd say like, I'm subscribing to this name, and here's the function for that. You do that in one step. And that would mean that like every time you do a subscribe, it has to do a lookup, and the publish, more importantly, did the same thing. You say, I'm publishing an event with this name, and you have to go look that up in the events table. Whereas this pulls out subscriber and publisher concepts into separate objects. So rather than doing a lookup whenever you want to publish, it's actually just like a reference to an object that's in scope, which is a lot faster. So let's see if I can find an example in here. Yeah, so here's the publish API. There's this should publish, just ported over from the original Diagnostics channel. You're basically asking like, should I publish something to this? And like this current design has both the like original API, which is like the name and object all at once, and it also has the object API down here. So you can kind of pick and choose which you want to use. Like it might be a little friendlier to use the just do it all at once style up here sometimes, but if it's like really performance sensitive thing, then you might want to do it this way instead to avoid the lookup all the time. So like just did like up here, create a publisher for like, I want FS read file to emit some events. So I'm gonna create a publisher. I can like create that outside of the function itself. So I just create that at like, the top of the FS file. Like this is going to be the publisher for this function for the entire lifetime of the node process. I will never have to look up this event table again. And then just publish events whenever I need to. So the way this works, go here. These are the like all-in-one interfaces that basically call this publisher or subscriber, which is the lookup part of it, and then the publish, should publish, and subscribe are the actual action parts of it. So the publisher up here like either tries to find a channel that already exists or creates this new object, and then basically how this works is we keep track of all the subscribers. My local changes, I'm trying to do a slightly different version of this, but basically we keep track of the list of channels, the list of subscribers, and whenever a new channel comes into existence, then it will loop over all of the subscribers to see like, do you want to listen to this, or do you want to listen to this channel? And if so, then watch that channel. And then on the reverse end, whenever a subscriber comes into existence, it looks over all the existing channels and decides, do I want to watch this? And so subscriber just has this subscriber that takes a function and stores it in its own watch, its own like array of subscriber functions, but also adds it to any watches I'm already aware of. Add this, like subscribe to this channel, and then when something new comes into view, add all existing stuff in this subscriber list to that channel. So just continuously keeping the lists in sync, basically. This current design has like this subscriber, well, the subscription concept actually exists in this subscribable, which also exists on publisher. So publisher itself is just a names channel, and subscribable, if you try to listen to just the names channel, like by the exact name, then you can just go to it directly. Just put the subscription function directly in there, and whenever you publish, it'll trigger the functions. But this subscriber class is if you want to do like regex matching. So this subscriber, I'm saying like fs.anything. I want to listen to any fs event on this subscriber. And that's what this lets you do is like whenever the publisher with a new name comes into being, the subscriber will be notified about it with this watch method, and it'll subscribe to it. But it in here it does this pattern test, so it just like tests the regex. Does this match? If so, then watch. What I'm working on locally is instead of this current design where like Diagnostics Channel itself does this like check if I want to watch it and then watch it, and like does it has this subscriber lookup thing. I'm actually looking at eliminating this entirely and instead just have subscriber as an interface. So the idea is to model like with streams, you have kind of interface to like you create an object that has like an on read function or something like that, then do something. So the idea is for subscriber to just be an interface that is on channel and on message. So you just give it an object that has like when there's a channel, like whenever a new channel comes into being, call this on channel method on every subscriber I have. And at that point, the subscriber itself can do whatever checks it wants to see, like maybe I'm like trying to regex match this publisher name, or could be trying to do something else entirely, who knows. But this on channel method would just be responsible for doing the channel subscribe itself, if it wants to. And then it would like it would just like attach itself to the channel. Like it would subscribe itself, like pass itself in with this channel subscribe, and then the channel itself would just call the on message function on anything that's in its subscriber list. So it makes it so that the subscriber can be a bit more generic and we can have more control. It's like there's probably going to be some cases where like you just want to match the name exactly. There might be some cases where you want to like regex match. There might be some cases where you just want like the whole fire hose and you don't want to do any check at all. So on channel, you can just be like, yeah, channel subscribe to everything. That's kind of the idea that I'm pursuing at the moment. But yeah, that's the general idea is just to pull out basically create like an event emitter concept, but pull out the namespace concept into like actual separate objects, so you never have to do the lookups. It's like when you do publish or publish, it has the list of stuff right there. You just go straight to that and loop over it. So there's no like lookup by whatever the event name is or anything. It just knows where to find it a lot faster. And like I did some like basic benchmarking stuff down here, which I have. Where's this? This one I did like a basic comparison of this like if should publish. This is basically trying to measure what the overhead is if no one's listening, which like the intents, like I said, is for this to be a data fire hose. So a lot of the stuff probably would have no one listening to it most of the time. So this is doing a direct comparison of like, what's the overhead of just doing that versus just like counting increment iterator. And yeah, the numbers on this basically showed that like it the cost of the like should publish is about equivalent to just the incrementing. So it's like very, very low cost. So I think this is probably a reasonable way forward for this. I don't know if anyone has any opinions on how subscribers should be structured, just like what way we would want to subscribe. Like the one thing about this that like I've kind of been a bit on the fence about is like I split this out into these channel objects to pull the lookups out of band from the publish action. Because that's most of the cost. So if we can eliminate that cost from every publish, then that improves performance a lot. But in doing so, I ended up having to make it just basic string match. In this universal monitoring bus thing, I had this like more complex object-based lookup, which this is basically like an object subset match. So as long as the object coming in has at least this, then it is seen. And that I think is conceptually friendlier, but I couldn't figure out a good way to make that work well, pulled out of band. Because like a bunch of this data, you're kind of going to become aware of it over time. It's not going to be immediately available. Like something like span, you're probably going to know, and like namespace, you're going to know immediately. But like you might have like you do like an HTTP request, and you like look at like you might get the URL right away, but you might want like the status code or something like that. You want to look for things that have like 404 status code. Well, you're not going to know that until after the thing ends. So how do you subscribe to events that have that structure? So my thinking so far is just always listen to like a broader category and just discard stuff when you eventually decide it's not relevant. It's not ideal, but it works.
Um, should open to questions now. We have 20 minutes.
Just a sec.
So anyone has any questions you want to ask?
I have one question, but it's simple, I think. The goal of the diagnostic channel is a global channel so that it can be globally unified between modules.
Yeah, so it's the idea is to have it's basically like one event emitter for the entire process. That you'd have like namespaces, like you might have like MySQL module claims the MySQL namespace. So anyone that cares about MySQL is just going to listen to that name. And so like all of this funnels through one place, and it allows like it allows like all sorts of different modules that have diagnostic data that they think would be relevant. They can broadcast it, and then anyone that wants to receive that data can listen to it. So like an APM vendor could say like, yeah, we want to listen to like all the like, MySQL queries or something like that.
Okay, thanks.
Any other questions?
So does it mean that we will have a shared instance of monitor that shared across modules, and so that every modules can use that shared monitor to publish data and parameters. So I have concerns that if there will be any security issues around the use case, if we have a globally shared monitoring tools.
Yeah, so there's definitely a security concern to think about there, and I think we would want to basically document and like tell the users like this is a general channel, anyone can listen to this, so don't send sensitive data through this. It's up to the module what they want to send through it. So like with MySQL, like they might decide like we'll give it the queries, but we won't give it the values that are getting like injected into it. And like if we see something that's not a parameterized query, then maybe we won't send it because there could be stuff that people mixed in, or things like that. Yeah, just like, make it clear in the docs for this that this should be like generic diagnostic data and not anything security sensitive.
So as much as documentation can help, it doesn't really prevent any of these concerns. We learned that the hard way with domains. We had guidance on how not to use domains, and everyone used the domains the way it was not supposed to be used. So maybe to address the security concerns on this, we need to use the policy feature on NodeCore and have the policy for subscribers restricted by default, and and the app owners have to explicitly opt in a module to to be allowed to subscribe to the channel. So for example, the APM modules would request that policy, and the application would be able to allow it. But if another module that was not supposed to have this permission asks, the application can block it, and it blocks it by default. So with that, we would have a security first model that still allows APMs to use and implement things with this. Not sure if you think this is something that we could do.
Yeah, I definitely think the policy model would be reasonable. Yeah, the current state of the world is that APMs basically achieve this by monkey patching everything, and that capability exists for everyone else right now. So, like, if you really did want to intercept any of this data, you can already do it. Like, not really stopping anything. We're just making it a little harder for people to use the easy mode, I guess. But yeah, if people really want to hack the system, there's plenty of ways to do that, unfortunately.
Right. The runtime is not secure by default, but making it easier might result in even modules publishing things by mistake. So if we can avoid that, that's probably for the best.
Yeah.
Another thing I was going to ask is it possible to audit which subscribers exist? Like, is it accessible, a list of subscribers as part of the API, or is it just a private field?
So yeah, at the moment it's just using the underscore fields because I found a bug in V8 that made private fields not work. Apparently it was just fixed.
Yeah, it would probably be good to have a getter then.
Yeah.
Yeah. Anything else on the concerns about security from anyone?
A lot of this will probably change a bunch before I actually have like a PR to open.
I have another confusing point that if there is any comparison between the new diagnostic channels between the current implementations like monkey patching. So what problems does the diagnostic channels resolves regarding to the monkey patching? So I don't see very many comparison between those tools. So I'm confusing that if there is any problems that diagnostic channels actually resolving.
Yeah, so the idea of diagnostic channel is to eliminate the monkey patching as much as possible, which it's faster to go through like a generic channel like this than to like go through monkey patching. Monkey patching creates a whole bunch of closures and it can get very expensive very quickly. But also monkey patching is generally somewhat unsafe. You have to code very, very defensively, and you're trying to write patches for someone else's module, which is a moving target. Some of them can change features out from under you, and like, there's a few notable examples of like breaking changes in patch releases and things that I've seen before that I won't name any names, but some modules have like just completely changed features randomly at no particular trackable time and made stuff crash because like certain functions didn't exist or worked differently, or like even like tiny like barely observable things, like something becomes a getter instead of an actual property, or like things like that. It can be very chaotic monkey patching things.
Also, the diagnostics channel should be more auditable than monkey patching, so it should be more secure in theory.
Yep. Yeah. Stuff that is passed through Diagnostics Channel, if we have like some sort of policy control in front of the subscribers interface, then like anything passed into Diagnostics Channel is probably stuff that's like it's coming out of a function scope, rather than like the current monkey patching model is like we have to like patch prototype functions and like inspect the this on things sometimes, or like intercept arguments, like input arguments to functions, and like that's kind of risky and like not very secure and kind of gives us access to everything. Whereas with Diagnostics Channel, we have more controlled interface. The module can just say, this is the information I'm willing to give you. I can like verify that this is correct and will remain correct like in future versions and all that sort of thing. It's a lot more controlled, I think.
So I found that the diagnostic channel will have to have the module owners to be cooperative regarding the sharing the critical info on to the APMs. So yeah, the monkey patching don't require the module owners to do anything, but the APMs will do the most of the dirty work. So I find this can be a not a I found that this may not be a drawback, but it can still be a point comparing to the monkey patching.
Yeah, so with monkey patching, like, yes, like APMs have ultimate control. They can go in and like grab whatever they want. They don't have to ask the module for it, which there is a degree of freedom to that. But I don't think it's actually that much of an issue that's like we're handing control over to the module owners instead. Because like in the past, there have been cases where like plenty of cases where APM vendors have like made pull requests to a lot of these like common like popular database modules and things like that to do things like introducing async resource anywhere there's like connection pooling mechanisms, things like that. And like async resource is not the best example because it being experimental has sometimes been accepted, sometimes not. But assuming this becomes an actual like supported API at some point and not just experimental, it should eventually get to a point where like we can just go to a module and say like we want this data from this function. We'll just make a pull request to this module, including this. we want to get this data from you. Is this fine, module owner? Yes, this is fine.
So I found it may be helpful to compare this feature with other language implementations, like to what I have known that there is a stable API in Java and the JVM that we can instrument bytecodes into third-party modules, so that which is pretty much like the monkey patching. So if there can be a, like say, comparison between other language runtimes existing implementations, it will be maybe helpful to introduce new concepts like diagnostic channels.
Yeah, I think it helps to consider what other languages are doing, but only to a certain degree, just because, like, especially considering like comparisons to like Java or C# or languages like that, which are like compiled languages. They function a lot differently. They have access to the bytecode. We don't. There's just a lot of differences in what capabilities they have at hand to use to build something like this. So like C# does actually have something kind of like this, but they also have like bytecodes, like intercepting features. So you have a lot more control over everything. We don't really have a whole lot of control of the runtime at all, so kind of the best we can do is just make an API and ask people to use it. Like the more manual approach rather than handing over a whole bunch of controls to the APM vendors and saying just like go hack up the system. And, like, the current monkey patching is pretty much the bytecode equivalent, just really unsafe.
Okay, so we have 2 minutes left. I don't think we can add any other questions for today. I have a list of questions, but I'm going to comment on the issue so we can continue discussion there. Thank you for the presentation. It was really helpful. And hopefully we can move forward with this. It seems like a good thing to introduce to car. One suggestion I would add is, since this will be consumed by APM-like modules and will be implemented on frameworks and database modules and etc., we might want to have some maintainers of those modules in the conversation. So
Yeah.
maybe we can, for example, invite folks from Express or from the MySQL package to see what they think of the API from a subscriber, from a publisher perspective, and also have folks from APM, from many APMs to comment on the publishing side of the API. Just to make sure we are not introducing something that both sides will think is not that useful or is not aligned with how they would like to use it.
Yeah, I'll definitely try to get some more people looking at it, providing feedback before it's anywhere near landing. yeah, I have like three-month contracts to work on building this, and hopefully getting it landed. So I'm gonna take my time just building it, and like really want to make sure that we get this right, because like there's been a lot of effort around APM related features in Node Core over the history that have maybe not gone super well, or like have done things that turned out to not actually serve the ecosystem the way that they needed to. It's like async hooks was replacing async listener because async listener didn't actually do what anyone wanted it to, and now like async hooks doesn't really do what anyone wants it to. So there's like a bunch of APIs layered on top of that. Like there's execution async resource to try and like eliminate a big performance issue with it, and there's like async local storage, just kind of like abstracting it even further to a level that an APM might actually care about. Like I don't want to go through this like decade-long cycle of trying to introduce an API that actually works. So I'm gonna make sure we actually talk to the people that will be using this. Have a little more certainty this time.
Cool. Yeah, we should probably schedule a few one-off meetings if you want to involve the working group as well as these other stakeholders. So we can have a better time that works for those stakeholders as well.
Yeah. I'm hoping to have like an initial pull request for this open in like Node Core this week maybe, but just like work in progress pull request, just showing like this is the basic idea. Get like Node Core to comment on the direction, decide if there's any like really critical stuff, and then from there, like maybe a few weeks from now, start pulling in like more of the ecosystem to look at it more closely.
As it is today, you can probably publish it as a userland module to start getting feedback.
Yeah, maybe. So yeah.
It doesn't use anything from, like, it doesn't connect to any of the internal libraries right now. It's not using any C++ code. Like, it basically is file, so it could be a npm module. Maybe you could scope it so it's and keep like below the first major version, just so that folks don't start using it. But it should be better for folks to try it out if they can install with npm.
Yeah, that might be possible for just like an initial experimental kind of like demo version. But yeah, the intent is like very much for this to get into core, like specifically because like I want a bunch of core stuff to be publishing to this. It's like can't really have it in user land if core needs to publish to it.
Yep. Okay, so we are 5 minutes past. We could probably end here. We can continue some of the conversation on the Slack channel, and preferably any questions we can have on the issue, so we keep a record of it. Thank you everyone for participating today. Have a great weekend. Bye-bye.
You too.
Thank you.
Bye.
Bye.